So surprisingly, these fraction square roots gave a lot of people trouble. I think there was like 12 people that said they had trouble with these yesterday. So if we're going to simplify these square roots, the first thing we want to do is think of it not as a fraction inside a square root, but as two square roots in a fraction. Okay, guys. So root 36 over root 100. This makes it a lot easier for our brains to rationalize what we're doing on the top and what we're doing on the bottom. What is the root of 36? 6. What is the root of 10? Or sorry, well, I just said it. The root of 100 gives me 10, right? Now, in this question, it says simplify the following square roots completely. What's the most important word in that direction? Completely. All right, is 6 out of 10 completely simplified?
No.
No. We could simplify this fraction some more. To do that, it's kind of like how we do our factor trees. How can I break up the number 6? What two numbers multiply to give me 6? 2 times 3. What about 10? 2 times 5. Exactly. Okay, now I'm looking for a matching pair of terms on the top and bottom. Is there any pairs in common? Or any factors in common on the top and bottom? 2 and 2. I'm going to circle up those 2's, cross them out. 2 over 2 is just 1, so we get rid of that. I'm left with a 3 on the top and a 5 on the bottom. And I need to include a plus or minus sign in the front, because we don't know if this is negative 3/5 or positive 3/5 that we took out of the square root. It could be both. So we include both answers. All right, so you're only going to have perfect squares when you see these fractions. It's going to be nice and even. Whatever you get for your roots, you got to simplify those further. So give B and C a try now that we saw A. Solve your perfect square roots, and then further simplify that fraction after that. See if you can figure out B and C on your own. Completely simplify. We just work through the whole thing. You paying attention to that? Good. Break it to 9, break it to 6. Nice. Good. Very nice. We're just missing one thing in the front. Plus or minus. Not just a plus, not just a minus. Plus or minus. So good. What's the square root of 81? Good. So 9 on the top. And then what's the square root of this? Okay. So 9 over 6. Right, follow kind of what we did with the. We don't need to break it up into 9 times 9. It just turns it into
6 squared is
16. So the square root of 81 is just 9. The square root of 36 is just 6. Once we get to here, the square root sign has gone away, so I'm not sure why it's over there. You know what I mean? Good. Is that it? Is it 2 over 6? Sorry. Oh, I think you did 2 plus 10 and 6 plus 10. You gotta break it into what? Multipliers to get 12. Nice. 16 is 4 times 4. Yeah, so there should be a denominator still. 3 over 6.
So on the top, 3 times 3 gives me 9. On the bottom, I think 3 times 2 and 6. Yeah, just like that. And then for this one, the square root of 256 is actually 16. It's not 15.
No, you're good. This is why we're doing it. Good.
So with 12 and 16 divided by 2, and that's 6, which is nice. 6 is 3 times 2. What would 8?
4 times 2. So we're at 4 times 2. And then what number can you cancel? 4. There you go. What are we looking at? Perfect. Just like that. Great.
So for this one, root of 256 would be 16. 17.
Nice. Those are good. Very nice. Looks like you guys are getting it. So just so we're all on the same page, making sure we got it right. Square root of 81 gives me 9. Square root of 36 gives me 6. We break the 9 up into 3 times 3. The 6 gets broken up into 2 times 3. What can I cancel on the top and bottom here? Pair of 3's goes away. And I'm left with 3 over 2. Slap a plus or minus sign in front. And that's what we get. For C, root of 144 is 12. This one's a little bit trickier. Root of 256 would be what? 16. 16, right? So I'm going to break up 12 and 16. Well, 12, what two numbers multiply to give me 12? 4 times 3. Okay. How can I break up 4? 2 times 2. So 3 times 2 times 2 gives me 12. What two numbers multiply to give me 16? 4 times 4. And I know that 4 is 2 times 2. So I'm going to have 2 times 2 times 2 times 2. Is there anything I can circle up and cancel here on C? 2's and 2's. You may have done this a different way. Hopefully you'll see that you get the same answer. I cancel 2 pairs of 2's out. I'm left with a 3 on the top. And what am I left with on the bottom?
4.
Good. 2 times 2, leaving me with 4. Plus or minus 3/4 on C. So fractions, even though they're a little bit scary, it's all going to be perfect square fractions. So as long as you know your perfect squares, even if you don't know your perfect squares, we have note sheet 2 right about here that has all our perfect squares. You can see, oh, root of 256 gives me 16. Okay? So use that for sure. Then we got the next thing that you guys said that you were struggling with, some of you, which is okay. Negative perfect squares in the square root. Now this one is even easier than the fractions, right? If I have a negative sign in front of my root 25, well, what two numbers multiply to give me 25? 5 and 5. Okay. If I have a pair of 5s, right, let's just do this the long way. If I've got negative root 5 times 5, I take the pair of 5s and bring them out of the square root. Is there anything left over inside the square root? No. All I have is a 5. Am I going to put plus or minus in front of this one? No, I'm not going to put a plus or minus. That's right. I'm just going to put a minus because of this negative sign in the front. So there's one instance where we do not need a plus or minus sign. If the square root is negative, then the answer, our root, is just negative. Okay, keep that in mind. Give the next two a try. If you're stuck on those two large numbers, again, take a look at note sheet number 2 from this unit. It's got all of our perfect squares on there. Take like 60 seconds to get through E and F. It shouldn't take too long. That's right. Do you have note sheet number 2, just so you have it as part of your disposal? Yeah, note sheet number 2, the little half paper that's in our notebooks. Good. Good. Yes, sorry, I thought it said plus or minus. Good. All right, square root of 400, what's that going to give me? 20, because 400 is 20 times 20. I bring the pair of 20s out, slap that negative sign in front of it, no plus or minus, because my square root is negative, and I'm just left with negative 20. What's the square root of 169? 13. Throw that minus sign in front, and that's what I get. This is why we've been doing those perfect square look-at reviews, to get really quick, very acquainted with our perfect squares, so that we can do them fast, not have to worry about breaking them down. Speaking of breaking them down, let's simplify these next square roots. Let's take a look at G. I've got root 24. Is 24 a perfect square? No, 25 would be a perfect square like we just saw, but 24 is not. So if we have what's called an imperfect square, then we have to make a factor tree. With perfect squares like we just saw, at this point in the year, in the unit, we should know our perfect squares, make it go really quick. But if we don't have a perfect square, we've got to do a factor tree. So you ask yourselves, what two numbers multiply in this case to give me 24?
6 times 4.
6 times 4. Perfect. How can I break up 6? How can I break up 4? 2 times 3 and 2 times 2. I'm going to circle up my prime factors. I've got 2, 3, 2, and 2. 2 times 2 times 2 times 3. I'm going to put them in order to make my life easier. And now I'm looking for pairs. Is there any pair of numbers in here? Yeah, a pair of 2s. Should I circle up all my 2s? No, just pairs. Pair being 2 terms. You got to leave that third one behind. So the 2's come out in front. What gets left in the square root? The 2 and the 3. We can see we're multiplying them. So what number is going to be inside my square root? Well, what's 2 times 3? 6. So we brought the 2 out in front. The 6 stays behind. Slap a plus or minus on the front, and you've got your simplified answer. Same process every time. Factor tree. Circle up your prime factors. If you find a pair, circle them and bring them out. Whatever gets left behind gets smushed back together and multiplied. All right, give H and I a try. Same idea. Make a factor tree. Look for pairs. Leave your remainders inside the square root with H and I. And you're working on this, right? Remember my friends. Go ahead, Camilla. Come on, you gotta stay with us.
missing, a little plus or minus in front. The numbers are great. So we just break out 56. Is that a 4? Where did the 4 come from? So yeah, when we bring out the pair of 2's, they just become one single 2. If we had 2 pairs of 2's, then we multiply. Is it 7, 8? Can we split 7 as well? No. But we can split 8. Yeah, 2 numbers multiplied. 4 times. There you go. You got 4 times 2. And then how can I split up 4? 2 times 2. It's actually. Good. Yes. Nothing else branches out from the 7. We got a circle at the 7 and that third little 2 over there. Yes, that's good. So the 2, the 3, and the 5, they're all alone. There's nothing they can be brought out with. We just re-multiply them all. Yes, that's right. I know that looks weird. It looks weird inside the square root. No, this one. Go up that same side. That stays behind us. $56 would be 8 times.
You have that desk with nothing on it.
Yeah. So for this one, we got. Oh, we threw up for 5. It's got to get re-multiplied back in the square root. 12 times 10. 10 is 5 times 2. And then 6 times 2. 3 times 2. Oh, 6 is 3 times 2. I think you did 3 times 3. Maybe thinking of addition. Yes, except the 4 we broke it up into a 2 times 2. So now the 4 doesn't exist. We have 2 times 2 times 2 times 7. That little 7 up there, we didn't break it up. So erase that 4, just put a 7. Now we brought the 2's out, which is awesome. Now we've got left behind 2 times 7, which would give me what? Super close. There you go. You got it. All right, let's break these down and see. What 2 numbers multiply to give me 56? 7 times 8. Can I split my 7 up anymore? No. But can I split my 8 up? Yeah, what 2 numbers multiply to give me 8? 4 times 2. And my 4 is 2 times 2. So this is where I saw a lot of mistakes. Okay, I'm circling up all my little 2's. We know that. But 7 is also one of my prime factors. I saw a lot of people forget to include the 7. Just because it's larger than a 2 or a 3, it's still a prime number. We still have to include it in our square root. 2 times 2 times 2 times 7. What's my pair I can circle up? Pair of 2's. What gets left behind? 2 times 7. So my 2's came out in front. Slap a plus or minus with it. What's left in my square root? 14. Plus or minus 2 root 14. Now 120. How can I split up 120? 10 and 12. You could do 2 and 60. You could do 3 and 40. You could do 4 and 30. 10 times 12 is probably the easiest. All right? 10 is just 5 times 2. 12 is just 2 times 6. And 6 is 2 times 3. I'm going to circle up my 5, my 2, my 2, my 2, and my 3.
2 times 2 times 2 times 3 times 5. I got a lot of factors in there. What can I circle up and bring out in front? Pair of 2s. Now, I've got a 2, a 3, and a 5 left over. Is there anything else I can bring out in front?
No.
No, those are all just individual numbers. They have no pairs. So we have to re-multiply them all inside the square root. 2 times 3 gives me 6. 6 times 5 gives me what? 6 times 5 gives me 30. Michaela, go ahead. So we get plus or minus 2 in the front from my pair. All my leftover numbers get mashed back together to give me 30. You're welcome. Quick show of thumbs. How we feeling about doing those factor trees and doing all that? Thumbs up. We're feeling good. It's a good review. Makes some sense. Okay. Okay. Enough simplifying. Let's estimate. Another big word here that we got to know. Estimate. All right. If we're estimating a square root, we're not making a factor tree. We're not breaking it down. We're not simplifying. We are discovering where this number falls in between multiple perfect squares. To do that, the easiest way to do that is with note sheet number 2, which we hopefully should all have. All right. If I look at number A, or letter A, I have the square root of 60. What's the closest perfect square here to the number 60?
8.
Perfect square? The closest perfect square, yeah, would be 64. So 60, is that less than 64 or more than 64? Less. So it's going to be somewhere in here, right? In between 49 and 64 is the square root of 60. So it's greater than the root of 49. It's less than the root of 64. It's kind of how we're thinking about this. What's the square root of 49? 7. What's the square root of 64? 8. So if the square root of 60 is in between the square root of 49 and the square root of 64, then this is equal to somewhere between 7 and 8. Now you don't have to show all this work. You can just use your chart and look and see. But that's what we're actually doing. We're finding where this number falls between. We're looking to the roots. Boom, there's our answer, between 7 and 8. See if you could estimate B, C, D, E, and F on your own. We'll take like 2 minutes for that. I understand some of you guys are ahead, and I get it, and you're working through it on your own, and you're feeling confident. That's great. But again, these are the concepts that the majority of the class selected as things they needed help with. Make sure you're writing the word between when you're estimating. You guys already got the thing open? Yeah. Yes. Yes. Yep, just like that. Yes, so if we're looking at this chart, what's the closest big number to one third? Exactly, that's it. Between 11 and 12. Because 130 is between 121 and 144. You got it. It's not too bad, right? It's probably one of the easier things we have to do. Good. I didn't realize I put that twice. Oops. I didn't realize C and D were the same. My bad. your perfect square chart? Take a look. Oh, it should be right after this. Yes, right here. Right after. So, where would 130 go in this little chart? Where would it be between? We're looking at the highlighted numbers. So think of this like a number. You're going from left to right, left to right, left to right. Right there is going to be in between 121 and 144. So my answer is between 11 and 12. So we first looked at the big numbers, but our answer is going to be the small numbers that correspond to it. Does that make sense? Cool. It's like a, what is it called? Scavenger hunt? Guys, it's really simple.
Flash notifications. Yes, I have it. It's the best. Good shit.
How's it going? Give you a little bit more time to estimate those. We're missing something on the end though. If you want. How you doing with these ones? The estimating ones. Do you want them? The estimating ones? Let's say 9 and 6. Oh, no, 9 and 6. Good. Great job. Okay, good. So we got root 9. What's the one that comes after root 9? 16. So where are we going to be in between? The small numbers right next to it. There you go. Between 3 and 4. So you start by looking for the big numbers, and then your answer is the small numbers right next to it. All right, if you're moving, yeah. It has to be between two numbers.
Oh, so I have to put 2 different numbers?
Yeah, it's between two numbers. Do you have note sheet number 2 in your notebook? From the very beginning, can I see your notebook real quick, just to see?
My stuff is scattered.
Okay. Let's see. Hey, there it is. Look at that. Yeah, so you find like 130, right? Well, that's in between 121 and 144. So my answer is between 11 and 12. You put between 11 and 12. Just like how our answer there says between 7 and 8. Between 11 and 12. Yeah, because if we put root 60 in the calculator, it's going to be like 7.5, something like that, which is in between 7 and 8. Yeah. It's a way for us to figure out what number it is without actually figuring it out. All right, let's go over these so we make sure we got them all right. Where would 130 fall between? Square root of 130, where's that between? 11 and 12, thank you. What about the square root of 12? 3 and 4. Same thing for D, don't worry about that. What about 91? 9 and 10. And finally, 270?
Between 16 and 17.
Good, that was a little bit harder. Between 16 and 17. Great job. Questions I could answer on the estimating? Okay. Again, you got to make sure you're reading the directions, because on the test, a question that says estimate a square root and simplify a square root, the question is going to look the same. You got to make sure you're reading the words. Okay? Number 3, our word problems. This is from our most recent unit. a square box is 10 inches tall, find the diagonal length, that's going to be my C, of the box by drawing a diagram, labeling it, and solving. Well, the first thing we have to do is draw a diagram. That's easy because it's just a square box. I can draw a square. There it is. I know that this square is how tall? Anybody with me? 10 inches tall. That's the only number I get. Do I know how long the box is, Camila? Exactly. It's also 10 inches because this is a square. And a square has 4 sides that are all equal. Another thing we know about squares is that every corner is a right angle. So if I want to find the diagonal length of a square, diagonal from corner to corner, that's going to be my C value. Because again, it's directly across from that right angle square. All right? So I set up my Pythagorean theorem. I'm going to plug my legs in for A and B. Now I just have to solve for C. What is 10 squared going to give me? 100 plus 100 equals C squared. Add those up, what do I get? 200. Not so bad. What do I do now? Square root both sides, thank you. Is 200 a perfect square? No, it is not. Closest perfect square to 200 is 196. We're not estimating. We got to simplify, break this down with a factor tree. What 2 numbers multiply to give me 200? It's a bunch of different possibilities.
20 and 10.
20 and 10. Sure, let's do 20 and 10. You can do 100 times 2. But I'll do 20 and 10. 20 is 4 times 5. 4 is 2 times 2. 10 is 2 times 5. My prime factors are 2, 2, 5, 2, and 5. 2 times 2 times 2 times 5 times 5. Any pairs in there? Pair of 2s? Pair of 5s? This is interesting. Now we're bringing 2 pairs out. Okay, my 2s become a single 2. My 5s become a single 5. What's left inside the square root? Just a single 2. Okay, so I brought out my 2. Brought out my 5. What do I do with my 2 and my 5? Multiply them. Giving me what? 10 root 2. Anything else? C equals, sure. Anything else? Inches. We're solving a word problem. We have to include our units. In this case, our units are inches. Now, some of you hopefully remember the shortcut for our factor tree when we're dealing with a square. That'll come in handy on number 4. But that's our process for number 3. We draw the square. We know that squares have all the same size sides. Plug in A and B. Just solve for C. Now C is not going to be a perfect square, even though our shape that we're dealing with is, ironically, a perfect square. The number we get for C, we've got to break down with a factor tree and simplify just like before. So, if that makes some sense, give number 4 a try. It is a little trickier because the numbers are larger, but follow that same process. All right, I'll combine help for number 4 while we're working on that. And then we'll see. That looks great. Exactly. Yes. Okay. So we got the 2, the 2, and 2. How can we break down 25? 5 times 5, right? Hey, there's another pair. Yes. Yeah, let me say.
Which church is this one? Right?
Yeah, it's the yellow one. Hold on, it's we gotta wait a few minutes. Just to, I'll let you know. I'll keep looking. How'd you do? Good. And you remember the shortcut. That's awesome. Good. So 40 squared. 40 times 40. Over 4 times 4. Good. And then there's 2 zeros that you just throw on the head. So 1,600. So we get 1,600 plus 1,600. Go ahead, Kim. Nice. Now we just gotta break that big old number up. Good. You see the pattern with the squares? Our answer is always going to be very similar. Good. What are my units? We don't want to just eat on air with our units. We got specific units.
They do the 0.2.
Yeah. It's always going to be in the problem. We're giving number 4 try fellows, right? We set it up. It's 40 inches tall. It's also 40 inches wide. Right? So those are your legs.
Don't touch it. I will go back. Did I do it like you? No, I don't do mine. Can you wipe it off? I will go back. How do you wipe it? Oh, you're right.
Well, if you put 2 together, I'll go back. That should be your answer.
Maybe you would be working back if he's one.
Me? No. Wait, hold on. What?
Kevin, question? Oh, okay.
What?
Larissa, question?
No.
Okay. Can't forget about the units. We're solving the word problem with units.
It's your birthday. What is it? What is it? I'll make sure.
Good. Nice job.
I got I'll make it. Then I give up on that.
All right.
It's never gonna happen.
Let's go through number 4. So, most of us got it done. I got a square TV, 40 inches tall. That means it's also 40 inches wide. I'm going to set up my Pythagorean theorem. 40 squared plus 40 squared equals c squared. What is 40 squared? Anybody?
1600.
1600. All right, so I get 1600 plus 1600 equals c squared. What happens when I add those up? 3,200 equals c squared. Then I take the square root of both sides. Now let's talk about our shortcut that we learned. 3,200, pretty big number, right? I don't want to break that down all the way because it's going to take me forever. Here's the easier way to break this up. And this is whenever we are dealing with a square, we can use this shortcut. All right? 3,200. If we look a step above, we see that 3,200 is just 2 1600s. So I'm going to say that's 1600 times 2. Yes, you could also do 32 times 100. But this is easier. 1600 times 2. All right, well, in the step before that, we saw that 1600 was 40 times 40. So I'm going to break 1600 up into 40 times 40. Typically, what we would do now is go 4 times 10 and 2 times 2 and 5 times 2. But I don't need to do all that. I've got a pair of 40s and a 2 left over. So what does that look like? If I'm in the square root, I got 40 times 2. My pair of 40s comes out in front. My 2 gets left behind. And I have 40 root 2 as my answer. All I'm missing is my units. What are my units here? Inches. You have to include your units in your answer. 40 root 2 inches. Now that's interesting. I had a 40-inch tall square, and my diagonal was 40 root 2. I had a 10-inch tall square, and my diagonal was 10 root 2. If I had a 30-inch tall square, my diagonal would be 30 root 2. If I had a 500-inch tall square, my diagonal would be 500 root 2. So hopefully you see that pattern. That'll help you check your work a lot easier on the test that we're taking in 3 days. Any questions I can answer about the square stuff? Okay. Now this is where in every class there was 20 plus people confused on the graphs. But in reality it's very simple. This is just the Pythagorean theorem. A squared plus b squared equals c squared. Only difference is we don't have my a and my b listed. We've got to figure them out. So I'm going to take my 2 legs. Here's one leg. Here's another leg. My legs are any lines that are not diagonal. There they all are. And I just need to count. See how long each leg is. In 5A, one of my legs is 1, 2, 3, 4, 5, 6, 7, 8 units long. And one of my legs is 1, 2, 3, 4, 5, 6 units long. All I did was count. So for A, I'm going to plug in 8. For B, I'm going to plug in 6. And my third side, C, is what we're trying to find. Find the length of the hypotenuse. What does 8 squared give me? 64, thank you. What about 6 squared? 36. Add those together, what do I get? 100. Take the square root of both sides. C is equal to 10 units. Nice perfect square, 100. They're not always going to be perfect squares. But we do always need to put units on the end because we're talking about a measurement on a graph. Right? You put units on the end, right?
Huh?
Oh, no. What?
What?
You didn't hear what I said?
You said that I didn't get something.
You didn't put units on the end? But you got to put units on the end because we're talking about a distance. So follow that pattern. Just count the highlighted legs. Those are the two numbers that you're going to square,
I'm sorry.
add, and take the square root of. Nice. Don't forget units. Don't forget your units. We're talking about a distance here. A distance on a graph. We need units on the end. Good so far. Nice job. Let's see. Go ahead.
Oh no?
Yeah.
I'm not trying to find B or C.
Yeah. Here, we'll get to that in just 1 second. I'll show you. All right. Quickly going through B and C. B, one of my legs is 6. One is 3. 6 squared plus 3 squared equals C squared. 36 plus 9 equals C squared. 45 equals C squared. How can I break down 45? What two numbers multiply to give me 45? 9 times 5. 9 is 3 times 3. I got a pair of 3s, a 5 left over. C is equal to 3 root 5 units. And number C, one of my legs is, what is that, 6? No, 5. One of my other legs is 5. 5 squared plus 5 squared equals C squared. 25 plus 25 equals C squared. Add them together. 50 equals C squared. Take the square root. What two numbers multiply to give me 50? 2 and 25. 25 is 5 and 5. I've got a pair of 5s with a 2 left over. C is equal to 5 root 2 units. So they're not always going to be perfect squares, but we do know how to simplify, right? Hopefully. All right. Any questions on those graphing ones? I know that it was a little bit confusing because we learned it slightly differently, but the idea is the same. So the ladder problems. We have to be very careful with the ladder problems because they're going to be asking for different things. The picture is always going to be the same. I'm going to have a little shed or a building here. I'm going to have a ladder leaning up against it. And I'm going to have some ground in between those two bases. That's what my picture should always look like. You could add the, rungs of the ladder if you want to. But we should see a nice, clear, right triangle created by the space in between. That's the main goal with this diagram. Okay, your drawing doesn't have to be perfect, but we should see a nice, clear right triangle in there just like that. Let's read this problem. The base of, that's supposed to say, of an 8-foot tall shed. But the base of an 8-foot tall shed, okay, right away, I know that my height is 8. That's one piece of information that I'm given. The next sentence says the base of the ladder is 6 feet away from the base of the shed. Well, here's the base of the ladder. Here's the base of the shed. So this distance must be 6. What I need to find is the length of the ladder. What letter can we assign to our ladder? C. My legs are 8 and 6. I can set those up. 8 squared plus 6 squared equals C squared. And I'll let you solve that one out. With number 7, you're doing the same diagram, but you're given different information, which changes what you're plugging into your equation where. Yes, it was. Oh. So we brought out a pair of 2s and a pair of 5s. All we have left over is that 3. You see what I mean? Yeah. Take more time, get a couple days. But we're not estimating on there. Simplifying. What did you do? Oh. Good. Not today. Yeah. Study guide. We're reviewing the study guide tomorrow. We'll turn both these in tomorrow. So hold on to it. So number 7. Again, it's the same type of problem, but we have different information given to us. We're given that the base of a 10-foot tall shed has a ladder leaning against it. So we know the height is 10. That's one leg. But this time we're actually given the length of the ladder, 20 feet long. So that's going to be your C. Your ladder is always going to be your hypotenuse. What we don't know is how far away the base of the ladder is from the base of the shed. So in number 6, we have a missing hypotenuse. In number 7, we have a missing leg. Again, that changes the way we set up our theorem. All right. So there is number. See the other ones on the hood?
Oh, I knew that.
There you go. So there's number 6. Go ahead and work out number 7 on your own.